Hello, I'm Kengo Suzuki, an assistant professor at the University of Tsukuba, Japan. I'm in charge of education and the doctoral and the master's degree programs of risk and resilience engineering and the College of Engineering Systems. I'm very happy to have this opportunity to speak to you today. My laboratory focuses on studying the relationships and interactions between the engineering systems and society. This is to support the consensus buildings and decision makings related to energy and environmental systems. Our research questions include what kind of energy system is desirable for the society as a whole? What types of rules and policies are necessary to achieve such an energy system? And how to share the knowledge obtained from data studies with public. One of the research methods we use to elicit answers to this question is called gaming simulation, or simply gaming. What kind of image do you have of conducting research using games? You may imagine game theory if you have studied economics. Alternatively, you may recall experimental studies using prisoner's dilemma games if you are familiar with psychology. However, many people may wonder if games can be used as a research method in the first place, and what can be achieved by using these games. This course is intended to those who are not familiar with gaming. I will talk about the characteristics of gaming in the academic field and how the adoption of gaming can lead to successful outcomes. Further, I will explain how gaming contributes to research and education by addressing global sustainability issues, including those related to energy and environment. This course consists of 6 lectures in total, including this one. I hope this course is useful for a diverse range of people, such as those who want to learn about gaming, those who are looking for guidance around the solving real-world problems, and the students who are considering joining our laboratory. Okay, let's start today's lecture. On looking up the word gaming in an English dictionary, it says the playing of games, especially those developed to teach something or to help solve a problem, as in a military or business situation. This definition reveals that the use of games to solve real-world problems began in the military and business fields. The most famous war game appears to be chess. It is said that the game Chaturanga, which originated in India, was introduced to the West and evolved into chess. The Chaturanga was also introduced to the East, where it evolved into shogi and has very similar rules to that of chess. Chess and shogi are models of real-world war in that players try to capture the king or the opponents by commanding different types of military units. However, worlds represented by chess are very abstract. The game board is a homogeneous plane divided into squares. The strength of both armies is exactly the same. Pieces move one by one, and all the information is already known. From the end of the 18th century to the first half of the 19th century, more concrete and realistic war games were designed in Europe, especially in Prussia. The Kriegspiel, as shown in the slide, is one such game. The Kriegspiel was designed by a Prussian army officer named Reiswitz and is used for training and research. This game can reproduce battlefield in much more realistic ways than chess because it uses a map based on real battlefields. It asymmetrically arranges forces of both armies according to each scenario and hides some information from the opponent, such as position of the enemy's army. There is a referee in this game who operates the game board, dealing with the player's commands according to the game's rules. The referees play a similar role to that of computer programs in today's computer games. Although I'm not very familiar with this field, the military continues to use such games even today. We can find a variety of literature on this subject in the database of academic papers. Next, let us look at business games. One of the most famous games in this field is a beer distribution game, which was developed in 1960 by Professor Forrester of the MIT Sloan School of Business. The game models the supply chain of beer. Players divided into 4 roles: retailer, wholesaler, distributor, and manufacturer. The beer produced by the manufacturer is first delivered to the distributor and then to the wholesaler and the retailer. Finally, it is sold to the consumer by the retailer. Each player can only take 2 types of action: order beer to the upstream player and ship beer to the downstream player. Other types of communication, such as conversation, are prohibited. In each turn, the retailer is told the number of orders from the customer by the game facilitator. The retailer then decides on the number of orders to submit to the wholesaler. Based on this information, the wholesaler places an order with the distributor places an order with the manufacturer. The information goes up the supply chain. The manufacturer then decides on the amount of production and the number of shipments based on the information that comes up the supply chain. The distributors then decide on the number of shipments and so on. The beer goes down the supply chain. Due to the time taken to the communication and deliver beer, there is a time lag between retailers' orders and the delivery to retailers. When you actually play this game, it often happens that production increases significantly and inventory builds upstream in the supply chain, even though demand has increased only slightly. This phenomenon, where fluctuations downstream are exaggerated while being transmitted upstream in the supply chain, is called the bullwhip effect. This effect is a known factor hindering efficient production control. I participated in an academic workshop to play the beer distribution game. In the workshop, those playing the games learned about basic problems related to production management, and participants then discussed how to make the supply chain more efficient. You can find various articles and videos about beer distribution games on the internet. Please do some further reading if you are interested. Even today, business games are used for training and internships in private companies. In Japan, there are various types of business games dealing with different themes, such as corporate accounting, retail store opening plans, restaurant management, mental health management, and job hunting. Furthermore, at international conferences, I have participated in games that aren't specifically oriented towards the Japanese perspective. These include representing negotiations between semi-public operators and invested in the operating companies, and a game that discussed ways to improve human relationships in the workplace. In this way, games have been used in practice for a long time, and the trend continues nowadays, especially in military and business fields. So, why have games been considered useful in these fields? To answer this question, let us consider the characteristics of the game medium. First, a game is a kind of model that expresses the constituents of a system in the real world, and the relationships and the interactions that affect and change these constituents. In the case of military games, example constituents of a battlefield are the terrain and army units. Rules that change these constituents are, for example, soldiers that are damaged by combat, or the requirements for soldiers to consume food every day. In the case of business games, the constituents of a system may be production capacity and inventory volume of factories. Rules that affect the constituents may be the cost for transporting products and time for transmitting information. In this way, a game is a model of the target system, and gameplay is a kind of simulation. Of course, it does not matter if you make a mistake in a game. You can try again and again and find out how to achieve a better score or result. However, if a game is nothing but a simulation, you need not get the human players and have them play the game. The multi-agent simulation on the computer can completely substitute the gameplay. So what is the point of humans playing games? According to the study book called Rules of Play, game design is a second-order design problem. A game designer indirectly designed the experiences of players by directly designing rules. In other words, a game is a medium that gives players a virtual experience. Players take on the role of military commander in military games, or company owners in business games, and repeatedly make decisions to achieve given objectives, such as a tactical victory or current account surplus. In games, players will face a difficult choice because the game reflects certain challenges or difficulties in the real world. For example, in military game, suppose you and your opponents are stuck in a battle. Then the opponent suddenly shows a small weakness. If you have an all-out attack at the exact moment, you will have a 70% chance of winning and a 30% chance of losing through counterattack. If you do not make an all-out attack, the battle will end in a draw. Looking only at the probability of winning, it appears you are safe to make an all-out attack. But can you really make that decision when you become a commander in a real-life battle? From this point of view, the same situation may look different compared with when you were observing an audience. In this way, the representation of reality through games has two aspects: mapping and metaphor. Mapping is to create models that objectively represent their state and behavior by observing research objects such as battlefields, companies, and energy systems. On the other hand, the metaphor is to design a subjective reality in which the participants feel as if they are real stakeholders of the real problems. The objective constituents of the system and the subjective reality of the stakeholders of the system interact with each other. In a battlefield where two armies are fighting, when both commanders give orders, the battle situation changes depending on the combinations of their orders. The commanders change their perception of whether they are at advantage or disadvantage, considers what to do next, and then fear, joy, sadness, or impatience. Such a subjective reality consisting of thoughts and emotions influences the next command. That command changes the battle situation, which then changes the subjective reality, and so on. In this way, the media of games can simultaneously describe the objective state of the target system and the subjective reality of the people who operate the system. It can also express the dynamic interactions between the subjective and objective aspects of the system. So, is it possible to utilize features of games for research and education in fields other than military and business? There are, in fact, such efforts being made in various fields. For example, in Japan, gaming is used in disaster prevention. Although I'm not an expert in this field, I'm interested in disaster prevention games and have read some research papers and participated in gaming workshops because there are specialists in disaster prevention and urban reconstruction and the risk and the resilience engineering degree program that I belong to. For example, I have played a game called HUG, which had a theme of running an evacuation center. This game models an evacuation center immediately after a large natural disaster such as earthquake and is overwhelmed by various people of different ages, family structures, and nationalities. Participants learn about what kind of problems occur in the actual evacuation center and what kind of preparations are necessary in advance. Of course, it is important to prepare for natural disasters on a daily basis, but there are few opportunities to learn from actual experiences. Therefore, it is an excellent idea to learn from virtual experiences created by such a game. I'm particularly interested in gaming related to the sustainability of technological, social, and environmental systems because my research focus is on energy and environmental systems. Water resource is one of the most common themes in this field. The water flowing through the river is used for various purposes, such as drinking, agriculture, and power generation. In other words, various stakeholders with different purposes are lined up along the same river basin. So what happens if everyone consumes water to the level they desire? The river may be dry up in the brink of a night, and if people upstream monopolize water resources, the people downstream are likely to get angry and a conflict will occur. Gaming is useful to prevent such discord by designing a game that represents the current situation of the people living in the river basin, and then invite them to a gameplay session. A discussion can be facilitated around the result of the game, and ideas can be exchanged. In this situation, the game has two roles. First, the game represents the objective structure of problems such as lack of water and unfair distribution as a result of egoistic water usage. Second, the game enables participants to virtually experience the subjective reality of other stakeholders. By playing the game, participants can empirically learn that each stakeholder faces different problems, and it would be better for everyone to make some rules and manage water resources together. Such recognition can be groundwork for constructive discussions about how to use water resources in the future. In this way, the media of games can dynamically and simultaneously express the objective and subjective aspects of various issues in the real world. By taking advantages of these games, my laboratory aims to clarify various factors hindering sustainable solutions to energy and environmental problems, propose ideas to address these factors, and inform the public of these findings. In this lecture, I talked about the features of games and presented examples from various fields, including military, business, disaster prevention, and sustainability-related issues. In the following lecture, I would like to introduce the scientific basis of gaming simulation, as well as the recent studies related to global sustainability. Thank you for your listening and see you next time.